You've heard this phrase before, APR, maybe on a commercial, maybe on an advertisement online, but what does it mean? Well, why don't you write down this definition? It's when interest is accrued or accumulated just once per year. And that interest rate is called the annual percentage rate, or the APR. Please get that down. Okay, here's the formula to calculate how much money you'll have, or sadly, how much money you will owe, if your interest is being compounded annually. This is a fancy way of saying that you'll be hit with interest once during the year. So pause this video, and I would highly recommend getting down all of this, especially what all the variables stand for. All right, so what do these values mean? This means A equals the accumulated balance after Y years. Another way to say that is the amount of money that you have. P is the starting principal, how much money you are starting with, either how much debt you're starting with or how much money you're putting into a bank account or the stock market. That's your starting principal. Principal means the starting amount. The APR, of course, is that annual percentage rate, and you want to put that in as a decimal. So for example, 5% would be equal to 0.05. And Y stands for the number of years that you're either investing or you're being charged interest for some sort of debt. All right, so here's what a problem would look like. You give $5,000 to a bank, we'll say a bank, and they give you 4% interest. It's APR, meaning it's compounded annually. How much money will you have? How much money will you have after 10 years? All right, what does this look like? Well, the amount that you have is going to be equal to the principal. That's that starting value. Well, you're giving $5,000 to a bank, so that's going to be $5,000. And then 1 plus your APR. Well, if you're talking about 4%, think that as 4.0. You're going to move your decimal twice to the left. That decimal is going to disappear. I put in the 0 here. That's a 0.04. And then we're going to raise that to the power of how many years have we invested? Well, that's going to be 10 years. So please pick up your calculator right now, and you're just going to put this in exactly as is. If you're confused about how to do this, you're going to use that caret button to bring your values up, meaning get that exponent. So tell me what you get. I get $7,401.22. If you don't get this, make sure we talk about this in class. All right, so pretty simple. This is the original that you start with. That's your percentage, and this would be the number of years. And you just got to make sure you're plugging into your calculator correctly. Fortunately and unfortunately, sometimes interest is paid more than once a year. This is really good if you're investing money in something that you're getting a percentage out of. This is really bad if you're talking about credit card debt. All right, we're not going to represent anything on Excel. It's just going to be too tricky with remote learning. But we are going to take a look at this question right here. Let's see. Yeah. All right, Avery deposits $5,000 into 2 banks. At Cole's Awful Bank, they give 6% simple interest monthly. At Nadia's Amazing Bank, they give 6% interest compounded monthly. Well, let's go ahead and do the one that we're familiar with now. The 6% interest compounded monthly. You should pause for a second and say, this doesn't quite add up. This is monthly, And the formula that we had before was for APR, which is annual percentage rate. So you should say, hey, Ms. Sorensen, this is going to be a different formula. And you're totally correct. It's going to be this formula right here. And I will come back to this problem for sure, but let's make sure you get that formula down. Let's see if oh, there we go. It's much bigger for you. So pause the video, get that formula down. I recommend getting down all the variables as well. All right, you're back. So let's go ahead and let's try this problem. All right, giving myself a little bit more room here. So for compound interest that's happening more than once a month, we are going to use this formula. So the P is the principal still, and then we still have that 1 plus. The APR is going to be the interest given, the APR, but then you're going to divide by the number of times it's compounding. So for example, if this is talking about monthly, you're going to get 12 compounding periods a year. So if you're talking about monthly, N is going to be equal to 12. If you're talking about daily, your N is going to be equal to 365. If you're talking about weekly, there's 52 weeks in a year, so your M is going to be equal to 52. All right. So in this particular problem, we know everything we need to plug into this. So the amount that we're going to have, and this is for the compound interest one. So what bank is this? This is Nadia's bank, compound interest. We're going to have our starting principal, which is $5,000. And then we're going to have 1 plus my APR, which is a 0.06. Divide that by N. Well, if we're talking about monthly, remember N is equal to 12 because there's 12 months in a year. And then we're going to raise that to the power of N, which is 12, times the number of years, which is how many years are we doing here? 10 years. So that's going to be times 10. Now, folks, if you have an old school calculator, you need to make sure you keep parentheses around this or else you're going to get your answer wrong. Take a second to find this with your graphing calculator and let's make sure we get the same answer. All right, for this answer, I get $9,096.98. And that's just a matter of plugging in correctly to your calculator. And I'm happy to answer any calculator questions in class for sure. All right, well, that's Nadia's bank, and that's compound interest compounded monthly. So that uses this formula. I won't ask you the next question, but I do think it's really important to understand. Let's talk about the answer for Cole's Awful Bank. So Cole's Bank. Okay, if we're talking about 6% interest and we're getting it monthly, well, then I'm going to take 0.06 and I'm going to divide it by 12. So 0.06 divided by 12 means that this is really going to get 0.005, or that's 0.5% monthly. So we take that 0.005 and I'm going to multiply it by $5,000 and I get $25, meaning for this simple interest, you're getting $25 each month. All right, so that's going to be 120 months. So 120 months times 25 gives me $3,000 worth of that $25 for each of those months. And remember, we started with $5,000 and we're going to end up with $8,000 total. So you can see that Cole's Awful Bank leaves you with more than $1,000 less than if you're getting compound interest. So compound interest is better when you are investing. Again, here's the formula, nice and big. Let's go ahead and do one more problem with it. All right. So let's say that I am investing $10,000 at, we'll say, 4% compounded daily. Okay, and we'll say for 20 years. How much money Well, first of all, you should first say it's compounded daily. So I need to be using this formula because it has that n value, the number of compounding periods a year. Well, if we're compounding daily, your n value is equal to 365 because there's 365 days in a year. So let's do this. We've got our amount is equal to 10,000 times 1 plus our APR, which is 0.04, divided by 365, raised to the power of my n, which is 365, times how many years? Well, this says for 20 years. Again, try this in your calculator and see if we get the same thing. I get $22,254.43. All right, so that's our last problem for compound interest that is paid more than n times a year. Let's finish off this video by doing one more of these problems. So here's our new problem. Carl has $4,000 in debt with a credit card company, and that has 24% APR, or compounded yearly. He doesn't pay anything for 10 years. How much does he owe on his credit card bill? As soon as you see APR compounded yearly, you know that that formula is going to be this one, the one for paying once a year. So the amount that he owes is going to be his principal, which is $4,000, 1 plus his APR of 0.24, and then for 10 years. So how much is he going to owe? Is it going to be a lot, or is it going to be a little? Well, I get $34,377.70. That's a heck of a lot of money that he's accrued on interest. So just be careful with which formula you use. If it's once a year, use this formula. If it's compounding daily or monthly or weekly or hourly, anything where it's more than once a year, you are using this lower formula here. Thanks for watching, everyone.